Very cool.
Dobro.
Možeš jedno išto gledati. Ako ćeš slušati, malo čuje moj glas. Čuje se muzika sad onako zabušena i sredina. Što da radim brojim, kao 1000, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Listi da ti izgleda motor ovo se. Čuješ da? Osna, mi ja se čuje. Ja sam spetna muzika sada, ali nema već. Čuje se ovo je dobro. Jel dobro? Pola, jel dobro? Alo.
Košao, ovdje konac. Evo još jedna tehnička proba, 1, 2, 3, 2, 2, 3, 3, 2, 3. Ne vidimo da se šta čuje. Ili ćete morati čitati susana. 1, 2, 1, 2. Mi smo tu u studentskom centru, isprobavamo zvuk. Ekipa u susjednoj sobi. Čujete li nas? Da nas čujete. Baš bi bilo dobro da nas čujete. A možda nas i ne čujete. No ne znam šta je.
Dobro.
Je?
Treba je gledati. Mislim, praća zvuk, no. Hajde gledati.
Dobro.
Ne znam što gledati.
Baš. Da. Dobro, mi se lagano skupljamo predavanje za 10 minuta. Neću sad gasiti stream jer ću možda izgubiti link. Da, 10 sekundi.
A?
10 sekundi.
Ono, došli tamo da vidiš svoje trbušine, tu šeći. To je, koliko sam. Sad, mi ćemo to...
Ja sam objavio na meetup stranici i na Facebooku, ali ne znam, možeš nešto šerat, neki post, nešto ovim svojima. Ja na
Sam se.
Developers meetup, tu Emir kad dođe, valjda će provat post ili nešto. Imamo event na Facebooku i onda će Emir valjda provat post kad dođe. Sad treba nešto popiti. Da ne pođe nešto kroz tu, ja ću... Sad ću ti čekati šta ti treba imam ja. Ali imam nekakav post. Trebamo neki staviti link. Ja sam to napravio kao post. Ali ne znam kako je to najbolje. Tu piše YouTube one post. Live stream available and blah blah blah. To bi trebalo staviti negdje, jel? Možda i gore u obavezi. Wow, to bi stvar trebalo nekog da se vidi, ne znam kako je najbolje.
Stranicu u centru bi staviti.
Baš u centru? Pa ne, treba na ovaj event staviti.
Samo ko u komentarima.
A može tako, ja. Ako sam zainteresiran za event, onda ćemo to valjda doći. Tu nemaš neta.
Da.
Čekaj, gdje su na eventu?
Ajmo da se proslijedi na Facebook i tako se koristi.
Treba ti na Messenger stavim taj link. A imaš? Treba nešto. Šti šta? Moram li će uvijek?
A?
Znači. Jeste vidiš? Ja moram da ne nekom tebe nešto. Malo.
Gledajte se. Travarica. A onda ćemo da.
Pozdrav.
Šta je ovo? Super.
Pa neko, kako je malo slabo.
Ja moram da je bio Karlovac pa da šeram. Tam dugo nisam išao.
Kaj nam to znači?
A?
Ne.
Kaj mogu mislim struje da? Ovo će raditi struje.
Viktor je ovaj.
Evo baš 7. Moje slike.
Aha, danas se probavali, onda će biti sve okej. Ja sam dobro stavio u centralni.
Tu radi čak, moguće onda vidjeti za ovaj kontakt.
Treba da staviti link na stream na Facebook. Na nekog smo stavili?
Ja, kao što se vidi da piješ pelin. Streamingu se vidi.
Ovo ćemo dobiti ono iznad 12 godina.
Vidite to što se potično.
Ovako. Da, to je to. Uz.
Kako kamerica to lijepo?
Znači dobro da je stavio.
Da, tako se vidi.
To se znači. Mislim, mogu ja još i linkić staviti u komentarima.
Možeš probati, zašto ne?
Evo, vidimo se nekako.
Da.
Sve se je koliko, točno 10 sekundi.
Je.
Ništa neobično će reći. Što se mogu gledati?
Dobro, šta ima, šta se događa s tom tehnologijom se zakapa? View, Angular. TypeScript je uvijek. Da, ono, to nije razvijesti. To nije razvijesti Visual Studio. Ili Visual Studio Code. Ili nešto treće. Zašto? Tako, vidiš se neki starter pack, ono, create, Angular,
NG Create.
I supportali da oni sami,
Baš i radi to. Kažeš production, ima se jedna situacija. Ono radi, treba otvorat, kažem da krije production, jedno 2 sata. Ne još više od plasnika. Neki komponenti, nešto ovo.
Ti si baš isto mučno, da to. Znači, rešivamo užasno stanje. Da se razvijamo i kada stanje konkurirane da budu. I ono kada su ovako konkurirane. Ne znam, što je to, ne znam, nemaš profil,
Nešto bez veze, da.
A je.
Ali, na primjer, ti pred mnogo praviš, nisi to svjesni. Zapravo moramo svakom toliko probati, da će raditi. Pošto ti se dovedeš situacijom da se drži. Ovo ne samo da napravi neki izbog. Drži se mi polat, znaš nešto.
I pokazuje.
Produkcijski.
Zato što radi optimizacija. To je samo ono što mijenjaš. Da li mijenjaš ti neko drugi
Sad više zapravo...
ne, ali čak i na drugo.
A da, što imaš dva različite sešća. To je da sešća pravila koje se mijenja. Za njih ti još tako javi grešno. Čak i čak i samo prođe.
Ja mislim da je cijelo samo da je plaća.
A, misli da će sebe se čustva.
I sad mislim da je
Može neki dan da nešto stave bolje.
Aha, super. Snima se, znači sve se snima. O, gospodo. Bravo.
Čekaj, sad problem. Ja sad možete došli? I da.
Možda je nešto familije to, kuć, neko zove stanje naše.
Daj neku prvi reći. Kako ne?
Hajde, da li mi tako snajte? Nice to meet you. No worries. Phone. No worries.
So he said that.
you know how good your card is? How good? Yes. Let's find out before we put it on. Hi guys. Yes, but I have like a new one. Oh, okay. Sorry I'm late, but they have very good pasta at Mona Lisa.
Do you have any secret material on this just right? So I said, hide it on the screen.
It's not the coffee, it's not the Where do I copy them?
Reservation. Good money. Wait. Нет. Was for I'm a stable. I'm a stable.
Schwätzen keine Ordnung.
Okay, thank you.
Pizza is coming.
Victor has a brand new materials.
All right.
First text.
The presentations of 45 minutes?
Yep.
Okay. Good. I got the second one then. Okay.
Prvo pitanje je bilo koliko je dobra grafička kartica.
Pa. Je to?
Dobro se pitanje. Koliko je dobra grafička kartica na grafička. Još moram raditi sad dokumentaciju, znači da zbog pizza moramo poslati. Dokaz da smo nešto dali.
Mi smo dokazne materijale.
Da. Where is this? Some videos for the change? Even better. The game itself. Yeah.
We are taking a bit of a chance here on our laptop, but maybe we're laughing.
Dakle, danas zapravo gledamo dan u životu jednog gaming developera. Kao što vidite, to uopće nije različito. To je skroz isto kao što je nama samima. Neko ovdje baš radio neke ovako video zahtjevne igrice. Ne zahtjevne. Dobar dan. O. Ne bi. Imamo možda roterija.
That's what I also do at the university classes in algebra. I always take the batteries from the projectors.
That's my tax credits here.
And you never return that.
Actually, Victor, are we ready?
Almost.
All right, then I'll give you a few church announcements.
Please.
Hvala što ste došli u ovako velikom broju. Prvo bih pozdravio Viktora, onda naše dugoročne članove i tako da vidim. Ovo je prvi povijesni stream jednog meetupa. Viktor će predavati na engleskom, pa se ja mogu prebaciti na engleski jezik. Few interesting things are happening in our community. We have, I guess, first IT conference in Bihać in Bosnia and Herzegovina. It's on 10th May. Some of us will attend for sure. It's on Thursday, so if you're interested, you can contact us. It will be like, popular science in IT code. So it will be easy on everyone who's interested. And we were there a few weeks ago. It's a great place to visit, and it's great to see how our neighbors from the other side of the border are growing. Victor, just let me know when you're ready, and I'll stop talking. Otherwise, you don't have a chance. Okay, then Victor Popa. Well, we tried to find him from different angles, from Algebra University, and also from their meetup from Zagreb. They were nice to borrow us one of their member for this lecture. Victor, you have the floor.
Thank you. First of all, thank you for being here and for having me as a guest. As far as I understand, we'll be talking for 2 sessions, each of 4 to 5 minutes, right?
Yeah.
Okay. Because I also talk a lot.
Okay, we'll let you know.
So the first subject I want to talk about is video games in general. It's a more generalistic approach, and then we'll go into something more specialized, level design. Video games are an unusual mix of art, programming, and gameplay. So before we start, is anyone here a programmer? Okay, good crowd. Has anyone in the room tried to make a video game, Flash game, HTML, anything? We have quite a few people. Nice. So, especially for you, sorry if it's a bit too on the surface of a presentation, but it's just a warm-up. We'll go into more detail with the second one. So, are we still on? I'm Victor Popa. Before we begin, big thank you to Vedran and the rest of the organizers at Carnaval de Vita. There we go. I won't go into much details about me. You read way too much text already. Newspapers and Vedran make it sound bigger than life. Probably they're right. I'll go quickly into what, in my opinion, as a professional, is about what video games really are. We'll talk about 25 minutes about pipeline overview of how we normally look at the game in a professional environment, how we build a big project. We use as an example AAA realistic quality project. And we'll have 10 minutes at least for Q&A. So, just 5 minutes about me. I am an expert level designer, 12 years of professional experience in the games industry, which makes me feel old. Several AAA titles. My girlfriend actually made me change this line in the announcement. It's multiple AAA titles. And I've worked almost this entire 12 years entirely on multi-platform and multi-engine titles. So I don't think I worked on a single title to be published only on a platform, only on PC, or only on a single console. And I worked with about 6 or 7 engines, out of which 5 were built in-house by Ubisoft or Electronic Arts. So, to answer quickly the question, which engine is better, Unity or Unreal, my answer always is whatever works best for the project. I am a fan of Unreal in my spare time. So, what are video games? This is at least my answer, the way I see it after working for 12 years for video games. They are definitely an interactive media product. Actually, they are the single interactive media product on the market. Imagine going to a theater play, and halfway through the play, the actor stops everyone and starts asking in the audience, what did that character say 5 minutes ago? And if you don't know the right answer, the play starts over again. And I would like to put an emphasis on interactive, because even to me it used to happen. We tend to get lost in the beauty of programming, the beauty of modeling, the beauty of texturing, or the beauty of story writing, and what most indie small teams do as a, let's say, mistake if you like, but also big companies and wasting millions of dollars in the process, is we forget the about the interactive part. So let's get into a bit of detail about the interactive part, and especially why do we play video games. I don't need to make a show of hands with who played video games here in Swingos. Everyone raise their hand, right? So why do we play games? Anyone?
Okay.
Yes.
It's a big...
Yes. Anyone? Other reasons? Right. Definitely. They also make us feel good.
Spend the money.
Spending money. Exactly. Go back to the addictive part. We have a saying in the games industry when we play too much called try not sniffing your own product. So, my explanation would be that, okay, so this is the most successful picture in any presentation I put. I hope you like it. We walk around the world with the world's best problem-solving machine. We're talking about each and every one of us having a quantum computer inside. From time to time, I don't use mine at its best capacity. However, we were evolved into this huge problem-solving machine, very efficient, that can solve very complex problems. For instance, real-time physics, throwing a ball, etc. Even soft logic problems. Should I fight or should I run because the lion is attacking me, etc. Very, very complex problems. What should I do with my tribe? Should I move them and try to find for water and rains, or should we stay here and try to grow in an unfertile soil? If you notice, I deliberately mentioned problems we don't have today regularly in 70% of the planet. That's why we need to exercise it. Just because we have improved our lives doesn't mean the machine is aware of this. We're still used to solving problems and we get bored. That's why most of us will play at least a video game during their lifetimes. Because we need something work the machine. Before video games, we had Rebus. Yeah, Rebus, Enigmatic, everything. Mystery books, where you read about a mystery and you try to figure out who the criminal is, etc. That's why they're also addictive, especially for those that have better tuned problem-solving machines. Games start to become addictive. And one thing about video game addiction versus any other kind of substance addiction, for instance, or habit addiction, shopping, for instance, is that with video games, users rarely stay addicted to the same video game, except if it's World of Warcraft. We need to constantly find a better game that challenges us in newer ways, so we can find new problems to solve with our machine. Let's look a bit at what interactive actually means. So, as an art form, we are the only media type that presents a problem to the player, which the player must literally solve, provide input in any form, be it keyboard and mouse, be it controller, in order to modify the game world. So for instance, let's go back to the play theater. You have actors on stage that at some point stop the play and ask 2 + 2 equals what? And if no one shouts 4 in the audience, they don't continue the play. The moment someone shouts 4, they start the play again. This is an aspect, again, we should always remember and think about. Even if you're trying to build that weekend HTML game, at their core, if you strip away everything else, pretty graphics, multiplayer, story, art, anything, a game must give constantly problems to solve, through which when I solve them, I provide input to the game, and the game validates or invalidates my answer. Again, we look at a realistic quality project, so something more, let's say, AAA big company, but the pipeline I will present should apply to any kind of project, even that weekend game or that 24-hour game jam project. Here's the pipeline overview, and that's why I'm here. I hope everyone understands it. If not, let's go divide et impera on it. So, remember, we're talking about an unusual mix of art, programming, and gaming. Let's go through it step by step. Part of the picture I've shown you was the environment pipeline and the character pipeline. And to be honest, this is a shortened down version because I was running out of PowerPoint space presented. Let's talk just about the environment pipeline because this is a very simple example and we can easily pick it up and start discussing it. So we go from a 3D model built in a special software, 3D Studio Max, Maya, etc. We put on some 2D textures. If we're talking about a big project, it has to be photorealistic, so we're probably using a physically based renderer, which displays material as we see them in the real world. To compose those materials, we take those textures and we put them on a shader. And from that shader, putting the textures properly on the model, we obtain the 3D asset. From the 3D asset, we start building a scene with multiple 3D assets. And at the end, we actually get the level of the map if you also add in the level logic, like the gate that opens, the conditions for win and fail.
Can you provide more info on the shaded part?
Yes. All right. So, this is a polygonal mesh. It's a three-dimensional representation of a fence. Although I was born and raised in Bucharest city, I like to believe of myself as being a fan of the rural area. That's why I chose a simple picket fence. Okay, so this is again something we would build in SketchUp, 3D Studio Max, Blender, Maya, your 3D modeling software of choice. This is exactly how it looks like. It's just a simple monochrome representation of something, in this case, a fence. However, before we go into texturing it, we need to unwrap its surface because we have a 3D object that will use a two-dimensional texture. So we basically, if you remember a geography lesson, when at geography they present to you the various methods in which you can unwrap the globe. And you've got the American version and the British version, and in the 1700s they were fighting about which one is the most accurate, etc. We get exactly the same thing in video games. In those hardcore forums, that's what we talk about. The efficiency of the unwrapping of this fence isn't optimal in this solution. Anyway. Basically, we take the surface of the 3D object and we unwrap it on a planar square surface. Just to provide even more detail, this is what's actually happening. So I have this planar square checker pattern, which when applied to the fence looks like this, because every side of the fence has a corresponding region in the checker pattern. Any questions so far? No.
What's the difference?
Please. They're exactly the same, but this is how we usually work. This is how we test at the end to see if the squares are somewhat symmetrical all over, because this offers us the same texture density on the object. That's a advanced topic, we shouldn't have it there. Okay, now we prepare the textures. And we start, because it's a physically based correct renderer, with a base color. So in our case, we need a wooden plank color. And this is usually called color or albedo map for those who are into modeling. However, this would give us just a flat representation of the material without any kind of detail. That's why we add a roughness map, which describes where the material shines or not. Don't worry if you can't follow along. This is just an overview. It's not the main takeaway from today. So this one describes the way the material shines. For instance, even for example, a wooden plank is shinier on some spots and less shinier in other spots. For instance, the nerve of the wood is usually shinier and the white of the wood is a bit matte. That's where we define the shininess. Then we want to add some three-dimensional detail. But I say three-dimensional detail using the brackets because we're actually faking the way the light falls on a flat surface by adding shadows ourselves with the help of a normal map. Then maybe we actually want to displace those details using the more advanced video cards of today. And that's where we have the height map. The white stuff is what actually gets moved inside the video card so the surface doesn't seem flat anymore. And then maybe we want to make the places of the wood which are lower inside catch just a little bit of shadow, because that's what usually happens with objects in real life. And that's where we add the ambient occlusion. Now that I've confused everyone, this is how the shader looks like. And I hope this is a much simpler explanation. Basically, a shader is a piece of computer logic that takes all those textures, or even more, and puts them all on the same material. So basically, we instruct the engine to use all these textures in order to make a proper plank-like texture, wooden-like texture. It's good that we have a lot of wood here as an example. The 3D asset, which means the 3D model with all those 2D textures interpreted by a piece of computer logic, gets this. It's the actual 3D asset. So now it doesn't look green or checkered anymore. It actually looks like it has wood on it. And once we make our model, we then put it in our scene. So this is an architectural visualization I'm currently working on. It's not finished yet. But for the sake of this presentation, I thought to add a bit of those wooden fences next to the house. The architect will probably get upset because this house is supposed to be at the seaside, definitely not having one of those wooden fences, but hey. So all that trouble we went through before was just because of this tiny little fence. And if you want to extrapolate, think about all the trouble you have to go through for all the objects in the world, trees, etc., all the characters in the world, just to make them show up. Not to move, just to show up. I'll see if I can surprise you, but at the end of the presentation, nobody needs surprises during the presentation. Now let's look a bit at the programming details. Again, it's just a scratch on the surface, not much detail. What I showed you as an end result was happening in the game engine. But in order to get that picture with that fence next to a house in the game's engine, I had to use special exporters that connected 3D software to the game engine, so file format. I had to use a file format the engine recognizes. Then I had to go in the editor of the engine to create the shader, to place the object, to make the scene, etc. If we assume our game being AAA blockbuster also has a multiplayer component, we most definitely have an online service for the game, which literally means a lot of servers in the room connected to a very good internet, which which allow players from across the world to connect and play on the same map. How are you doing so far? Okay. So, funny story to relax a bit after all this technology stuff. At Electronic Arts for FIFA 17, which was the first FIFA game that had story mode, I was in charge of saving the user's progress. And when we're talking about a video game that, among other things, and when we're talking about a video game that sells to so many people, I actually had to get information to consult, if you like, the online department about the frequency of the saves I'm allowed to make, because I wanted to save as much progress as possible, as often as possible, because just the amount of users in the world contacting the server to send their save data and to get it back, if done too frequently, would have added expenses of a few $1 million just to operate the data centers all across the world and literally pay for the internet bill. So that's why we optimized it. And although on your console we save locally every match you play and every progress you make in the campaign, we only send to the server at the start of each chapter. Because this way it's cheaper, we don't burn the servers, and we don't need to buy another entire server farm to support a single game. But that's the size of the projects we're talking about and how big they can get and how just a tiny little detail can mean the difference between a company going bankrupt or a company making profit. I won't get into much more detail about programming, but I'll leave you with this food for thought if you want, especially for the programmers in the room. This should mean something. GTA 5, which yesterday was announced to be the most profitable media product of all times, having sold so far $6 billion worth of copies and content and whatnot. If we look at it with the editor, with the tools, with the game code itself, we're talking about approximately 100 million lines of code. I don't want to crush any dreams, especially because we have young people in the room, but you can make up until some point a game by yourself. However, if you want to achieve greatness, you have to learn how to be a team player. And I don't think regular programmers here can help me. Can you even write 100 million lines of code in a lifetime?
Yeah, how big was Linux kernel when it was 5?
I don't know, but Windows isn't there yet, so yeah.
It looks like a lot of legacy code.
Yes. However, who dares remove that before release? So yeah, my question should have been, can you write 100 millions of quality code in a lifetime? So, if we go back now to the pipeline overview, it's not that complex anymore, I hope. Again, this was the environment, this was the code part, and this was the character pipeline. The main difference between characters and environment is that aside from everything we do with the static objects, we also need to animate them and to make those animations logically linked together in an anim tree. So that means basically instructing the model on what factors it should switch from walking to running, or from running to jumping, and how it should blend between the two states. Something us people do like that. Again, powerful machines. So everything I said earlier, confusing and a lot, and something I don't even master well, and I don't think there's a single person that could master all of it well, is just to entertain our brain. So yeah, next time when we think about a game, think just about the effort a team of 100 or 200 or 300 people have put in just for, let's say, 1 or 2 hours of our entertainment. If we like, 5 minutes if we don't. Okay. We could maybe discuss a bit about what I just presented, so if there are any questions.
If you say something like full stack gaming developer, so are you doing all this workflow from 3D model to programming? Doing animations, doing...
At an amateur level, I'm doing it. So, for instance, I'm able to create a pickable object in an already existing engine, to give it shape, to make it say that fence, and to give it a condition. If I pick it up and put it in another part, I could do this. However, even engineers, like serious engine programmers, are specialized. In a big team, it's regular to have 5 engineers, senior programmers, working on just the shading aspect, just how we represent those layers of information to make wood look even more realistic. Whereas you could have 5 or 10 more working on animation. At FIFA, we had more than 20 programmers and technical directors working on the animation system. That's why FIFA has the best animation systems in any video games in the world. That's why it doesn't look repetitive. That's why we actually believe, kind of believe the players are there. Although I'm no longer affiliated with Electronic Arts, I can still say PES shows the repetition more often because they don't have that much code behind their animations. I think they have more code behind their shaders. So that's where those programmers work on PES. As for gameplay, on a game like GTA 5, I expect to have at least 30 programmers working just on the game logic, as in drivable cars, every kind of interactable object. Can I open this door? Can I jump this fence, etc. Destructible props, etc. So again, if you're doing a 2D project that takes you 3 to 6 months, yes, you can probably write your entire engine from scratch. You could write a simple 2D animation system, 2D sprite system. You could do everything. You could even paint everything in Photoshop. Big projects require a lot of man-hours. It's not about intellect. It's just about how much time we collectively spend and how much that time would double, triple, etc. if it would be just one person. Any more questions?
I guess you're planning to explain what roles do you have in the system that's coming up next.
I can do that.
And the other question is, what can you buy?
Sorry, what can you buy?
What part of the...
So,
yeah, what can you buy?
as we have the colors here, we look at simple roles. So we usually have in the game production team, so aside from marketing, localization, etc., just the team that actually makes the game work on a computer or on a console. Blue line would be level designers, environment artists, game designers, so those concerned more with how the game world looks like. Purple would be character artists, those concerned with how the characters look like. And red or orange would be programmers. Each of these job families can then separate based on the actual specific thing they do. We could have level designers who actually craft the world and the logic inside it. We can have something I was for quite a time, technical directors for level design. My job for 4 or 5 years at Ubisoft was to design the tools with which other level designers would build an entire world afterwards, and to assist them with documentation about the features programmers would build. So, for a simple example, we would build truck deployment system. Did anyone here play Ghost Recon Future Soldier? No. Okay, any kind of video game where soldiers jump out of a truck and they attack you. Okay, so in order to achieve that, we have to make those trucks have some deploy points where the soldiers actually jump out. Based on the distance of the jump, which the animators would give us, we would have to put a constraint, so you can't stop the truck next to a building and those soldiers would jump through the building. And all those kinds of rules, like the maximum curve a truck can take, the maximum angle of a slope a truck can climb, in a big project are compiled by a person like me, agreed with the programmers, made in a pretty manual, so we can go straight and read the manual, and distributed to the world builders. When we're talking about production, like any kind of Ghost Recon title or Assassin's Creed, etc., we're talking about making sure this information reaches at least 2 or 3 studios in the world. So I literally was visiting Canada and France and sitting together with the team of level designers that were going to use those trucks, presenting how the system works, getting feedback from them, challenges, edge cases for truck usage, etc. And then, if you think about it, in the same game, you also have planes and helicopters and boats and running around. So it's a really, really complex beast. I hope that answers at least a bit the question. If not, I can continue. Any more questions? Please.
How does the engineer recognize when a character can move or jump 1 meter high or 1.1 meter high can?
Very good question. So game designers usually set the world rules. As a game designer, your main concern is to think, before it even happens in the engine, what would you like your character jump height to be? Then here, at the engine level, programmers implement those restrictions. However, if we just say, okay, the character can jump at 1.5 meters height, that's not enough. We need the animators to come in and make that jump animation look perfect for that 1.5 meters, because a believable human character would prepare itself differently for an animation for a jump that has to happen at 1.5 meters versus a jump that should happen at 20 centimeters from the ground. Maybe we want the character to also be able to fall. So if you don't get the jump just right, to fall, then we would need to transition from animation to actual physics ragdoll, we call it. It's a controlled physics switch on the character, where we basically calculate how the character would fall as if it would be a ragdoll. So then we go back to the programmers to add more complexity to our project, and so on. To answer your earlier question, what can you build versus what can you buy? There is a company that created an animation system called Euphoria, which they then sell to video game companies. So you don't have to use 20 of your programmers in order to have believable animations. GTA 5, for instance, is using that plugin. So they were able to program helicopters, dogs, driving cars, chasing around cars, racing cars and boats and planes and everything else, because they got the package with realistic human animation behavior. What else can you buy, for instance? Well, you can get for free Unreal Engine or Unity and have all the interface between your game and the actual computer. That's what they do. They ensure that your game logic, your game design, if you like, the jump height, etc., can work the same on a computer, on a mobile phone, on anything. Any more questions?
How do you go about structural 3D models?
Yes. So, how we add complexity to this. Thank you, thank you. If I would have wanted that fence to be destructible, let's say when we hit it with a car, it breaks, because that's what wooden fences do. The 3D model would need to be split up plank by plank, or fragment of a plank by fragment of a plank, saved as an identical copy of the original, which is a single object, with some programmers to script the state change. So basically to add the logic of saying, if any car hits this fence, then switch from normal fence to broken fence. And then enable physics on each part of that fence and let it fall with gravitation. And with the impulse of force the car applies to that fence, and any angular force, so the fence jumps exactly in the direction the car hits it. Then we would say we need some splinters for the fence, because when wood breaks, it breaks with splinters. So we would have to call an ethics artist friend of ours who is specialized in making bullet impact, splinters, sparks, glass breaking, etc. And he would give us somewhere around here at the 3D asset stage an FX, basically a smoke puck, a wooden splinter puck, if you like, which we only show exactly when the fence breaks into pieces. So as you can see, that's why I said at the beginning of the presentation, this is a simplified version of what a pipeline looks like. You usually learn this in your first 3 to 4 years as a developer. It doesn't matter which path anyone in this room decides to go, amateur or professional, programmer, artist, animator, ethics artist, game designer, it really doesn't matter. If you stick with it and do it for fun and you enjoy what you're doing, in about 3 years after you start, you can draw this and explain it to anyone else, and hopefully not make them follow. Okay, please.
What about the nations of animals? How are they handling it?
Yes. Very good question. Very good question. Humans have the advantage of being cooperative, and if you pay them well enough, they actually let you record their motion with a complex system which requires their own technical directors and programmers, yes, called the motion capture. So we strip tiny little white spots on the person, we film them from all the sides, we interpret the spatial movement of those points, and basically we digitize the motion of the bones in that person's body into our game. FIFA, for instance, have a football stadium-sized motion capture studio where, yes, you guessed it, they literally motion capture Messi and all the good players. Yes. That's why FIFA is so well branded and has 80% or 90% of the
So they pay to Messi to come to the studio and run across the stage.
all of them. all of them, all the top players from the top teams, because that's how they make their signature moves.
Yeah, you can really see. You can see which are cheap players. They have like default animations.
Yes.
Then you can see Messi and other guys. They have their ticks and everything. Their movement. It's
I think this
It's
is not,
scary.
I think this is not a video game. This is they play it in the TV.
So now, to get back to the animal part, with animals it's a bit harder because they don't tend to cooperate when we try to stick a lot of tiny white points on them, and they don't necessarily do what we tell them, like move that way, walk, don't run, look forward. No, we actually go about it the Pixar way. It's literally hand animation. We recreate the animal skeleton in the editor, and we move each part of the body at each moment of the animation. Yes, and that's why manual animation, if you like, in my opinion, will never die. As long as we have Pixar, who has to show us rock golems and all kinds of goofy characters which we can't literally find in the real world, like a talking teapot or, I don't know, a talking car, if we're looking at cars. Those still have to be animated by a real person. So someone sits at the computer and moves each wheel of the car and moves the mouth for each sound it makes. And again, they also use hundreds of animators in order to make an entire movie. So that should be still here, animations and Anime Tree. Any more questions, or can we jump to the second presentation? Cool. So the second one will be a bit more user-friendly, I hope.
We want to grab a drink or something now.
Yeah, we can.
Who wants some?
Coffee. Just a very short black coffee, and I'll put some water on the tea.
Oh, really?
Yes, Croatians make very strong coffee.
That's fine. Ej, Martin, uvijek Martin ide u link, onaj robot, onaj pratitelj. Gorec. Nešto, onako, odlučivanje, da, i onda to gdje se došao. Zapovjeć sam još, ali ne znam što sam to vidio. Nisam ja znao da FIFA ima takav animacijski studio veličine stadiona. Ajmo teret tamo predavača, hoćemo dalje.
Onda je to to. To mi je rekao da je igram. Onda 7. 8. ništa, kao isto je.
Smo se čuvali ono tamo sa...
Čisto da znamo.
Začepite pa će onda opet morat. Na oče, da. Na oče. Na oče, sad ću biti do toga da mi reći. A ne, neće sad, malo da će tu kada. Nekako je zašto peše tamo.
Da bi to bilo hvala.
Šta?
Oni otiču ti rano na Evropsku. Sada ti ja velim da sam bio u Tirani. Bio su skopi.
Ti, sad je to, sad je cool, jedno drugo, šta je? Imaš šmingu.
Ne, se briga, brate.
So before we start the second presentation, I shouldn't put that much liquid next to the laptop, first of all. Next to the mic.
And
So we'll do this at very low FPS. Sorry if there are PC Master Race members in the house. Very low FPS, but it still works. So all the trouble we went through in the first presentation, very low FPS.
Excuse me,
Yes.
how do you get the high FPS?
With a better video card. Or lower resolution assets. So, for instance, remember the plank, the fence we talked about. If I remove bump simulation, if I just make it look flat, it will run faster because I load one less texture in video card memory and I make one less calculation when trying to apply that texture to the fence. I'll try to move a bit closer. There we go. This is also very beautiful rock.
How did you make this?
This is an executable, so it's just this scene with all the textures, etc. takes 3 gigabytes of hard drive. So sorry, I copied a lot of stuff on your computer.
It's not mine.
So the rock looks this beautiful because again we use a process called photogrammetry. So we go out, we make pictures in the real world at different exposures, and we extract from them all those 6 textures I showed in the previous presentation. The assets are taken from the free asset kits from Unreal. The fence is something I built today before catching the bus. I'm sorry, if you noticed, let's try to also rotate a bit. If you noticed, let's go there where we have the shade. Much better. The planks are cut on the middle, so each strand of wood isn't properly seated. That's because I really didn't want to miss the bus, so I didn't have time to arrange the texture better on the model. And I think we can actually see, if we look from the side, you can actually see how here it seems a bit indented. That's one of those normal maps and the bump maps that gives this illusion. If we just optimize and take those two out, it will look flat and just painted on it as it's shaded. So your eye will spot the difference and would say, ah, this is not real, it's a simulation of sorts. It's not real because that's not how objects look in the real life. That is called advanced topic thinking. So that is called Z-fighting. When we're trying to sort through which object renders over another, when we put 2 polygons in the exact same space, the video card doesn't know which one to render. And I'm actually pretty fast. Thank you. This is called the Z-fighting because the video card decides alternatively and sometimes randomly, depending on the way the engine works, which will display. So they're literally fighting for the same Z-axis position. Okay? And talk a bit about the grass. I will probably kill the executable when we start. So the grass, for instance, is lit differently compared to the trees and the fence and everything. If you look at the fence, we actually see, and on the building, we actually see the so on the fence and on the building, we actually see the projection of the tree leaves and the tree trunk, etc. This occupies a lot of memory because we can't do it real time yet. So we have to save those shadows in yet another texture we apply on objects. However, the grass, because it's so much of it and it would take too much computation to apply shadows to each and every part of it, is just shadow, like we say this one maybe is in the shadow, this one is in the light. So it's binary, it's either shaded or lit. Okay, enough with the demo.
Which tools did you use?
Unreal Engine. Yes, I got the mesh from an architect. I'm trying to help her visualize buildings in real time. The environment is from an asset pack. I just arranged stuff there, and the face was entirely built by me and not properly Okay. So we talked about the engineering part, the pipeline, how things sit together. It was more of a technical discussion. And although this is a bit more of an advanced topic, it's also a bit more friendlier. So if you resisted the urge to leave so far, thank you very much. It gets fun now. Because I'm not that good at programming, I guess. But also because I like to study how people interact with the game more than to actually write the code that makes the game work. I would like to tell you why I think being a level designer is awesome. So, I'm Victor. Here's what we'll talk about. Another aspect of who I am. I'll try to tell you why in 12 years I didn't go to programming or towards programming. I didn't want to write that much code. Possible, and that's probably how I got to be a technical director. If I can find someone to write code for me, that's even better. I will also show you why I refused, for instance, to be an artist, to make trees and textures and to go out and take pictures of rocks. We'll also go through a practical example, which will work in perfect FPS because it's a video. And I also have a few closing words.
What is level design?
Game designers think about the whole idea of the world. The jump height a character in the world can do, the speed with which a car can move in the world. The power of explosion when a car hits a fence. Level designers, if just a scratch on the surface, but I'm going into more detail, are those that decide and try to please players by putting the fences properly, by adding more or less cars in an intersection, by creating puzzles for the players with that specific jump height. We'll go into a bit more detail. So these are all the projects I've worked on, but so you don't get bored, let's go to a story-like presentation. So I got my first job as a level designer more than 12 years ago. Yes, I know. For a small company in Romania called Popa. I spent about 2 or 3 years there. I eventually became a lead level designer, and the publisher working with that company was called Activision. Did anyone play Cabela's Dangerous Hunts? Nice. For Cabela's Dangerous Hunts 2, I was a level designer there. And for the PSP version, I was lead porting it to the portable version. Then I moved in my career to become a technical director for level design, coordinating the tools and the discussion between level designers and programmers. So again, not programming, just talking to programmers. This really shaped up my logic. Just by hanging out with programmers, you don't have to be a good programmer at all. If you just hang out with programmers, in 6 months to a year, you will start to understand the logic and sequential thinking better. Just because that's what they do all day. And they're pretty awesome to be around. I've also been a lead level designer. So for instance, has anyone played Watch Dogs 1 or 2? Ghost Recon, Future Soldier, or Wildlands?
Except Future Soldier.
Okay, nice. Rayman, Raving Rabbits. There we go. So yeah, I've worked on all those titles at Ubisoft, you guessed it. And I eventually became a producer for EA Sports, working on FIFA. However, here are my notable achievements and where I've learned the most. Being a technical director for Watch Dogs 1 and 2, being a lead level designer for Ghost Recon Wildlands, that was really something. And of course, being a producer at FIFA. So, especially for you, who's younger, you don't necessarily have to think of your career as being a complete awesome bundle of joy. From time to time, you work on lesser known titles, such as Harley Davidson or Dangerous Hands. I didn't get much answers in the room. But if you just persist and get better at it, at some point, you'll get there. And I couldn't have been a producer on FIFA, I couldn't have made it as a producer on FIFA without level design. I worked on the core product, so that means the actual gameplay part. I didn't interact with the football players. There were other producers in charge of getting Messi in the motion capture studio so he can shoot at the goal with all the dots on him, etc. I worked on the way people play the game. So, to answer the question about what a level designer does, we build a physical world in which you play the game. It can be, in GTA, for instance, part of a city. It can be, here's a good one, the puzzle board in Candy Crush. The way the puzzle board is constructed, where you can play and where you cannot, is thought of by a level designer. Here's an example of a physical world from a first-person shooter. The easiest one to throw. We are architects of how people play the game. We are the ones that think of how many jumps, one after another, you must make in order to reach that coin at the top of the puzzle. Basically, we try to lure you into deciding which way to go. And let's talk about this really simple picture. Which way would you go? Who's for left? Left. Who's for left? Okay. Who's for right? There we go. So we work with lighting cues, with architecture cues, with psychology sometimes, in order to direct the players without telling them where to go. So if you ask me as a level designer, any kind of video game, first person, that puts that marker with go there, has failed in terms of level design. If you need to literally put a spot in the world where the player has to go, that's not good level design. If you can make most of the players subconsciously decide to go the way you want them to go, that's good level design. And we have clear intentions for the players to achieve actions or goals during the game. We literally control their emotional responses. I strongly believe that video games are not just about problem solving. You throw a problem, you solve it, give us an answer, and so on. About emotion. This is a clear example of how we want you to achieve something. There's only one exit out of the labyrinth. You're trying to solve the labyrinth. So if we do the labyrinth right and we put enough breadcrumb trails and suggestions and lights and landmarks, you'll get to the end. As I said, it's also about emotions. And for the emotions part, what does this picture suggest to you? So what's the first emotion you're feeling? Okay, so what's the emotion?
Motherfuckers.
Yep. So could we say anger, maybe?
Determination.
Determination.
Yes, stupid, not, you know.
Okay, let's play the video. And this works in perfect FPS.
You will score.
Do we also have audio?
Probably.
So, that scene, how did that make you feel?
Yeah.
Yes. So, it's the start of a level I built, and I wanted to put the player in the level when he's starting the level in a mode of not knowing exactly where he is and what's going to happen. After some gameplay, we get to another level. What about this one? Yes. You see a bigger shot, you see your friends, they're not necessarily scared, so they're not crying for your help. They're like, if you could get us out of this sticky situation. So you start to feel excited because, okay, it's Gears of War, so it's natural to be shooting everything that moves. You get excited about the fact that with your buddies, you're gonna shoot everything that moves. And after a bit of doing just that,
There's a lot of black nights.
a lot of shooting. We get to another sequence. The boss is coming. Oh, what happened there? By the way, does anyone... Sorry? Yes, it's actually a cutscene. Does game physics, you mean? Yes. So very bad animations. Does anyone recognize the helicopter crash scene? Close. Sorry. Yes. Yes. So by recreating the Black Hawk Down crash scene, I try to get the feeling you got to get from you the feeling you got when you saw Black Hawk Down. It's an action game, so I'm pretty sure most of the players of this game have watched Terminator, Black Hawk Down, etc. So I know I can make that emotional bridge by showing you the same thing covered in game assets. How does the player feel now when he has the sniper rifle? Does anyone know from psychology concepts when we fall the most? When we crash the most psychologically? Okay. Yes, that's a good answer. Yes, and when we lose our power, that's when we fall the most. Um, if I, for instance, don't have a good day, it's not a good day. I talk about it with my girlfriend, I sleep on it, and the next day would be better. When the president of the country, or the president of America has a bad day, he needs a lot of support to get through what he sees as a bad day. Yes, they solved it. So, first I gave the player a sniper rifle to make him feel powerful. And then we let him crash. So the red in the picture was because you feel powerful, you get surprised. However, it's a macho game, so the characters don't start crying or going into depression. They get angry and they want to fight back. And of course, that's what they do.
You decided to make a crime game?
No, definitely not.
All clear. Copy that. King Raven 2-4 is en route. Hold on. I'm detecting something.
You just need to run the car, right?
Yes. Almost. What movie was this one? Two. Yes. So, in the movie Godzilla, the one from 98.
It's allowed.
Yes. Yes. Genre. Yes. That one. The first part of the movie, when Godzilla comes out of the ocean, is filled with iconic scenes of little people running on the ground, and that was exactly the shot. The camera looks a bit towards the up angle, and the feet always trample through cars, tiny shops, etc. Again, I want to present big boss toning. I use Godzilla cinematography, so almost everyone in this room saw Godzilla. They immediately associate the big boss with Now You Run. However, it's a macho universe, so you have to fight it. So basically, I started with feelings, literally put them down on paper. I could actually send you the sketch I did on a piece of paper with what I want the player to feel. And then I constructed the game world, the cutscenes, and the actual gameplay, the accelerated parts, those cartoonish and accelerated, to support those feelings. And in the next 5 minutes, so we can have time for questions and maybe closing up, I actually go through a few. A small talk about level design and what we do. If I want to achieve stress, so not only the scenes where you get stressed because you're waiting for that helicopter and exactly when it arrives to pick you up, it gets shot down and complicates the problem. But I also, if you noticed, confronted the player with wave after wave after wave of enemies before the helicopter crash. So this mentally makes you feel like when the helicopter comes, you're like, yes, I've played so many waves, it's definitely my way out. When in fact, I just use those waves to build even more stress of losing the helicopter. Of course, that stress gets turned into disappointment when the helicopter actually crashes. Power, we already discussed this one, the sniper rifle, and also the way the fountains were built there, those things after which the player would cover, didn't let the enemies use movement from cover to cover to cover to cover to get closer to the player. So it was an advantageous design of the physical world in which you play, so you can use the sniper rifle efficiently. Because the enemy AI tries to make a path to come closer to the player by moving from cover to cover, and because they couldn't find another cover because of those long rectangular water fountains, they had to stay in the back, where their tiny machine guns weren't as efficient as the player's sniper rifle. Like, construct the feeling of power, and then surprise, you get ambushed. And surprise plus plus, for the programmers in the room, you feel smart when you blow their ambush. Because if you noticed, you just had to shoot a white gas barrel and destroy their machine gun nest. Right now, I'm also in the process of teaching everything I know about level design. I could talk about this for ages. I have an ongoing Indiegogo campaign. I'm building a course for Udemy, but right now, whoever wants to chip in on Indiegogo and help me build the course for Udemy can get the course when it's released at a considerable discount. So pick up a card if you need more info. We start right now. You can support the course with 15 euros and you get access to it start of May, somewhere in the first part of May. When it will be released, the course will be 200 euros. So we already have 28 or 30 people signed up because they think it's a bargain. Thank you, and if there are any questions, please feel free to.
Thank you, Victor. We have hot pizzas here, so we usually suggest that we switch for Q&A for the pizza side.
Yes, of course. Is it from
Some restaurant.
Okay. So I know where to stop.
People, thank you for listening. There are no pitches for you over there. Right.